x minus a and x minus a gets cancelled. What is left over is limit extends to of x raised to n minus 1, x to the power of n minus 2 into a plus x to the power of n minus 3, etc. a to the power of n minus 1. 3 into a to the power of 3 minus 1, that is 3 into a square. The simplified answer for this is 3a square is the required answer. That's it. Numerator, you can take x square common factor. In the denominator, factorize it. So you will get in the numerator x square into x minus 2. Hello dear students, welcome to this session of Mathematical Foundation class. I am Mr. Niranjan, Faculty Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Today in this session, I am going to discuss very important problems on limits, very important concept. Now let us come to the first. There is one theorem, very important theorem. Prove that for any positive integer n, limit extends to a of x raised to n minus a raised to n divided by x minus a is equal to na to the power of n minus 1. What is the theorem? To prove that for any positive integer n, limit extends to a of x raised to n minus a raised to n by x minus a is equal to na to the power of n minus 1. Now let us come to the proof for this. Now let me discuss the proof. Now just divide x raised to n minus a raised to n by x minus a by dividing x raised to n minus a raised to n by x minus a. By dividing x to the power of n minus a raised to n by x minus a, we are going to get x to the power of n minus a to the power of n is equal to x minus a into x to the power of n minus 1 plus x to the power of n minus 2 into a plus x to the power of n minus 3 into a square plus etc. The last term is a to the power of n minus 1. Suppose if you multiply this entire quantity by x minus a, you are going to get x raised to n minus a raised to n itself. So therefore, limit extends to a of x raised to n minus a raised to n divided by x minus a can be written as limit extends to a of this numerator x raised to n minus a raised to n can be written as x minus a into x to the power of n minus 1 plus x to the power of n minus 2 into a plus x to the power of n minus 3 into a square plus etc. plus a to the power of n minus 1 whole divided by what is we have in the denominator x minus a. Now this x minus a and x minus a gets cancelled. What is left over is limit extends to of x raised to n minus 1, x to the power of n minus 2 into a plus x to the power of n minus 3, etc. a to the power of n minus 1. Now put x is equal to a here. If you put x is equal to a, then this becomes a to the power of n minus 1 plus a to the power of n minus 2 into a plus a to the power of n minus 3 into a square plus etc. The last term is a to the power of n minus 1. Now you know law of indices. Using laws of indices, a to the power of m into a to the power of n is equal to a to the power of m plus n. A to the power of m into a raised to n is a raised to m plus n. This can be written as, this is same a raised to n minus 1. Here this is a to the power of minus 2, this is a raised to 1 is plus 1. A to the power of n minus 3 plus 2 plus etc. The last term is a to the power of n minus 1. This is a to the power of n minus 1 plus a to the power of n minus 2 plus 1 is also n minus 1 plus again a to the power of n minus 3 plus 2 is minus 1 plus etc. The last term is a to the power of n minus 1. So this contains all a to the power of n minus 1, a raised to n minus 1 plus a raised to n minus 1 plus a raised etc. n terms are there. Suppose if it is 2, we can write 2 times a to the power of n. If there are 3 times a to the power of n minus 1. Since there are n terms, so we can write this as this is equal to n times a to the power of n minus 1, which is the required proof. That's it. Very simple and very important for 7 or 5 marks. See, Just by dividing x raised to n minus a raised to n by x minus a, we are going to get x minus a into x to the power of n minus 1 plus x to the power of n minus 2 into a plus x to the power of n minus 3 into a square, etc. a to the power of n minus 1. Therefore, this limit extends to a of x raised to n minus a raised to n by x minus a can be written as limit extends to a of the numerator can be written as this entire quantity x minus a into x raised to n minus 1 plus x to the power of n minus 2 into a plus x to the power of n minus 3 into a square, etc. a to the power of n minus 1 divided by x minus a. These two gets cancelled. What is left over in the numerator? Put x is equal to a to the power of n minus 1, a to the power of n minus 2 into a to the power of n minus 3 into a square, etc. a to the power of n minus 1. Now, by applying law of indices, a raised to m into a raised to n is a raised to m plus n, minus 2 plus 1 is minus 1, minus 3 plus 2 is minus 1, and the last term is same. So, since all the terms are a to the power of n minus 1, since there are n terms, therefore, we can write it as na to the power of n minus 1. Now, therefore, limit x tends to a of x raised to n minus a raised to n divided by x minus a is always equal to n into a to the power of n minus 1, where n is a rational number. N is a rational number. That means n is a positive integer or a negative integer, or a positive fraction or a negative fraction. So, n is a rational number where n is a positive number, n is a negative number, or n is a positive or negative fraction. For all the rational values of n, x raised to n minus a raised to n by x minus a, when limit extends to a is always equal to na to the power of n minus 1. Very, very important formula indeed. Now, move on to the problems based on this. Now, let us take an example. Now, evaluate the following limits. Now, this is limit extends to a of x cube minus a cube divided by x minus a. If you observe carefully, this is of the form. This is limit extends to a of x raised to n minus a raised to n by x minus a. What is the formula? N a to the power of n minus 1. So, if you compare this, what is n? N is equal to 3 and a is equal to a itself. See here, x raised to n is equal to 3 and a is equal to n a to the power of n minus 1. N into a to the power of n minus 1 means 3 into a to the power of 3 minus 1, that is 3 into a square. The simplified answer for this is 3a square is the required answer. That's it. Right. Suppose if you put x is equal to a straight away, what you will get? By putting x is equal to a, if you put x is equal to a, by putting x is equal to a, what you will get? A cube minus a cube divided by a minus a. That is nothing but 0 by 0 form, which is an indeterminate form. 0 by 0 is an indeterminate form. So, therefore, this can be evaluated using the formula only. Limit extends to a of x raised to n minus a raised to n by x minus a is equal to na to the power of n minus 1. N is 3 into a to the power of 3 minus 1 is 3a square. Now, move on to the next problem. Limit extends to 2 of x cube minus 8 divided by x square minus 4. Now, listen, suppose if it is like this, limit extends to 2 of x cube minus 8 divided by x minus 2, straight away we can write. So, here this can be written as limit extends to 2 of x cube minus 8 can be written as 2 cube divided by x minus 2. What is n? N is 3. What is a? A is equal to 2. Na to the power of n minus 1. N is 3 into a is 2 to the power of 3 minus 1. Now, this is equal to 3 into 2 square. That is nothing but 2 square is 4, 4 3 is a 12. 12 is the answer. Suppose if it is like this, x cube minus 8 divided by x minus 2. Now, let us come to this problem. What is the problem given here? Here the problem is x tends to 2 of x cube minus 8 divided by x square minus 4. This is of the form limit x tends to of x raised to n minus a raised to n by x raised to n minus a raised to n. Now, convert this into the form of x raised to n minus a raised to n by x minus a. Now, this can be written as limit x tends to 2 of x cube minus 8 can be written as 2 cube divided by x square minus 4 can be written as 2 square. Now divide by x minus 2 both in numerator and denominator. So this becomes limit x tends to 2 of x cube minus 2 cube divided by x minus 2 whole divided by again x square minus 2 square divided by x minus 2. So now if you observe carefully, this is of the form limit x tends to a of x raised to n minus a raised to n by x minus a, again x raised to n minus a raised to n by x minus a. Now what is the formula for this is n a to the power of n minus 1, n into a to the power of n minus 1. In the numerator n is 3 into a is 2 to the power of 3 minus 1. In the denominator n is 2 into a to the power of 2 to the power of 2 minus 1. Simplify this. This is 3 into 2 to the power of 3 minus 1 is 2 square divided by 2 into 2 to the power of 2 minus 1 is 1. So 3 into 2 square is 4 divided by 2 into 2. So 2 into 2, 4 gets cancelled. This is equal to 3. The simplified answer is 3 for this. That's it. Followed. Suppose if it is alone like this, we can evaluate. Since it is of the form x raised to n minus a raised to n by x raised to n minus a raised to n, convert this into the form x raised to n minus a raised to n by x minus a by dividing both numerator and denominator by x minus 2. The answer we are going to get is 3 for this. That's it. Now move on to the next problem. Now limit x tends to 0 of root of 1 plus x minus 1 divided by x. Suppose if you put x is equal to 0, then this becomes 1 plus, by putting x is equal to 0, what we will get? This becomes root of 1 plus 0 minus 1 divided by 0. Root of 1 plus 0 is 1 minus 1 by 0, that's equal to 0 by 0, which is again independent form. So this can be evaluated by rationalizing the numerator. So therefore this can be written as limit x tends to 0 of root of 1 plus x minus 1 divided by x. For this, just multiply and divide by root of 1 plus x plus 1 divided by root of 1 plus x plus 1. That means just rationalize the numerator, multiply and divide by root of 1 plus x plus 1, rationalizing the numerator. So this can be written as limit x tends to 0 of root of 1 plus x into root of 1 plus x is root of 1 plus x whole square minus 1 into 1 minus 1 minus into plus, it is minus 1 into 1 is 1. In the denominator you will get x into root of 1 plus x plus 1. Now this is equal to limit x tends to 0, square root gets cancelled, 1 plus x minus 1 divided by denominator is same, x into root of 1 plus x plus 1. So here minus 1 plus 1 gets cancelled. Limit x tends to 0 of, what is there in the numerator? X divided by, in the denominator we have x into root of 1 plus x plus 1. So x and x gets cancelled. Now apply the limit. Put x is equal to 0. Now put x is equal to 0. Put x is equal to 0. What you will get in the numerator? 1 divided by root of 1 plus 0 plus 1. That is 1 by root of 1 plus 0 is 1, root of 1 is 1 plus 1, that's equal to 2. So the simplified answer for this is 1 by 2. Very important problem. So you may expect this for a 5 marks, a 5 marker question. So whenever problem connecting like this, root are given, just rationalize it to cancel that root. Rationalizing the numerator, just multiply and divide by root of 1 plus x plus 1 by root of 1 plus x plus 1. So in the numerator, root of 1 plus x into root of 1 plus x is root of 1 plus x whole square, minus into plus, it is minus, square root gets cancelled, minus 1 plus 1 gets cancelled, x, and in the denominator x into root of 1 plus x plus 1, x gets cancelled. What is left over is 1 divided by root of 1 plus, put x is equal to 0, 1 plus 0 is 1, root of 1 is 1, 1 by 1 plus 1 is 2, 1 by 2 is the simplified answer. Hope you followed. Okay. Now let us come to the next problem. Limit z tends to 1 of z to the power of 1 by 3 minus 1 divided by z to the power of 1 by 6 minus 1. Now convert this into the standard form x raised to n minus a raised to n by x raised to n minus a raised to n as x to the power of n minus a raised to n by x minus a. Now this can be written as, let me write this as limit z tends to 1 of z to the power of 1 by 3 minus 1 to the power of 1 by 3 divided by z minus 1 whole divided by again z to the power of 1 by 6 minus 1 to the power of 1 by 6 divided by z minus 1. Just dividing both numerator and denominator by z minus 1. Now here this is of the form n a to the power of n minus 1. What is n? 1 by 3. 1 to the power of 1 by 3 minus 1 divided by n is 1 by 6. 1 to the power of 1 by 6 minus 1. So this is 1 over 3. 1 to the power of 1 to the power of 1 minus this is minus 2 by 3 divided by 1 by 6 into 1 to the power of 1 minus 6 is minus 5 divided by 6. So this can be written as 1 over 3 into 1 to the power of minus 2 by 3 into 6 by 1, 1 to the power of minus 5 by 6. Simplify. Now this can be written as 6 divided by 3 into, just bring this to the denominator, 1 divided by 1 to the power of minus 2 by 3 is nothing but plus 2 by 3, and this is also 1 over 1 to the power of plus 5 by 6. So 3 2s gets cancelled. 1 to the power of any number is 1, that's equal to 2. The simplified answer is 2, that's it. Okay. Now move on to the next problem. Limit x tends to 2 of x square plus 4x minus 12 divided by x square minus 2x. Now if you put x is equal to 2, by putting x is equal to 2, x is equal to 2, what happens? 2 square is 4 plus 4 2s are 8 minus 12 divided by 2 2s are 4 minus 4. We will get 0 by 0, which is an indeterminate form. So therefore convert this, factorize x square plus 4x minus 12 can be factorized as, this can be written as 6 2s are 12, this is x into x. So plus and minus, plus into minus minus, 6 2s are 12, plus 6 minus 2 is plus 4x. So therefore the factors for this are x minus 2 into x plus 6. Substitute here. This limit becomes limit x tends to 2 of, x tends to 2 of numerator x square minus 4x minus 12 can be as x minus 2 into x plus 6. Whereas in the denominator you can take the common factor, x is the common factor, x minus 2. Now this x minus 2 gets cancelled, put x is equal to 2. Now 2 plus 6 divided by 2. So 2 plus 6 is 8 divided by 2, that's equal to 4 is the simplified answer. Very important for 5 marks. Just factorize the numerator, you will get the factors as x minus 2 into x plus 6. So in the denominator you can take x common factor, x minus 2 gets cancelled. Substitute x is equal to 2, you will get the answer. Now move to the next problem. Now evaluate limit x tends to 2 of 8 minus 3x plus 12x square. Very simple problem. Put x is equal to 2, that's all. 8 minus 3 into 2 plus 12 into 2 square. So this is 8 minus 3 2s are 6 plus 12 into 2 square is 4. So 8 minus 6 is 2 plus 12 4s are 48. So 48 plus 2 is equal to 50. The simplified answer is 50. So this is from last year's question paper. So put x is equal to 2. 8 into 3 2s are 6, again 12 into 2 square is 4, 12 4s are 48, 8 minus 6 is 2, 48 plus 2 is 50. Now one more problem was there. So that is evaluate limit x tends to 1 of x square plus 1 by x plus 100. Same, this is also same. Put x is equal to 1. What you will get? 1 square plus 1 divided by 1 plus 100. 1 square is 1 plus 1 divided by 101. So 2 divided by 101 is the simplified answer. Very simple problem, right? Now move on to the next problem. Evaluate limit x tends to 2 of x cube minus 2x square divided by x square minus 5x plus 6. Now if you put x is equal to 2, by putting x is equal to 2, if we put x is equal to 2, what happens? 2 cube minus 2 into 2 square divided by 2 square minus 5 into 2 plus 6. 2 cube is 8, 2 square is 4, 2 is 8. Again this is 2 square is 4, 4 plus 6 is 10 minus 10. We will get 0 by 0 form, which is an indeterminate form. Again factorize the numerator and denominator. Denominator x square minus 5x plus 6 can be written as, factorize this, x into x, this is nothing but 3 2s are 6, minus and minus, minus into minus plus, minus 3 minus 2 is minus x, so minus 5x, the factors are x minus 2 into x minus 3. So the limit, given limit can be written as limit x tends to 2 of, in the numerator you can take x square as the common factor, x square is out, what is left, x minus 2 divided by, in the denominator the factors are x minus 2 into x minus 3. Now cancel this, x minus 2 gets cancelled, put x is equal to 2, what you will get, 2 square divided by 2 minus 3, 2 square is 4 divided by minus 1, that's equal to minus 4. Minus 4 is the simplified. So numerator you can take x square common factor, in the denominator factorize it. So you will get in the numerator x square into x minus 2, whereas in the denominator x minus 2 into x minus 3, x minus 2 gets cancelled, put x is equal to 2, you will get minus 4 as the simplified answer. Now move on to the next problem. Now evaluate limit x tends to minus 1 of x square plus 3x plus 5 divided by 2x square plus 10x minus 1. Now put x is equal to minus 1. If you put x is equal to minus 1, this becomes minus 1 square plus 3 into minus 1 plus 5 divided by 2 into minus 1 square plus 10 into minus 1 minus 1. Minus 1 square is plus 1 minus 3 plus 5 divided by minus 1 square is plus 1 into 2 is 2 plus into minus 10 minus 1. This is equal to 5 plus 1 is 6 minus 3 divided by 2 minus 10 minus 1 is minus 11. 6 minus 3 is 3 divided by 2 minus 11. 2 minus 11 is equal to minus 9. Right. So what is 2 minus 11? That's equal to minus 9. Divide it. 3 1s are, 3 3s are. So therefore the simplified answer is minus 1 by 3. That's it. Okay. So 1 square, minus 1 square is 1. Minus into plus it is minus 5. 5 plus 1 is 6 minus 3 is 3 in the numerator. In the denominator 2 into minus 1 square is plus 1, 1 2s are 2, plus into minus minus, again minus 1. So that is 2 minus 1 is minus 1, plus 1, 1 minus 10 is minus 9. Or this is 2 minus 11, 2 minus 11 is minus. So that's nothing but 3 by minus 9 means minus 1 by 3 is the simplified answer. Now move on to the last problem in this, that is evaluate limit x tends to 2 of x square minus 5x minus 2 divided by 2x square plus 3x plus 4. Now put x is equal to 2. Check whether you will get 0 by 0 form. If you won't get 0 by 0, the answer itself is the solution. Now this is 2 square minus 5 into 2 minus 2 divided by 2 into 2 square plus 3 into 2 plus 4. 2 square is 4 minus 5 2s are 10 minus 2 divided by 2 into 2 square is 4 plus 3 2s are 6 plus 4. So this is equal to 4. Minus 10 minus 2 is minus 12 divided by 2 4s are 8 plus 6 plus 4 is 10. So 4 minus 12. 4 minus 12 is minus 8 divided by 18. Minus 8 by 18 is the simplified answer. If you divide by 2, 2 4s are, 2 9s are. So minus 4 by 9 is the simplified answer. That's it. So this is how we are going to evaluate the limits. That's it. Okay. So minus 4 by 9 is the answer. This is how we are going to evaluate. These type of problems are very, very important for the point of examination. Definitely will expect one full question from this. That's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.